Hello. Today's video will feature a very nice analog multimeter, an Holosun, of course, Chinese manufactured analog multimeter that is quite nice and that has been manufactured almost 5 years ago. I think that it's very nice to still consider using analog multimeters because they offer you a very interesting insight into technology, how much it evolved, and of course makes for a very good practice product because you can understand better what are limitations in terms of measurements and how we probably managed to achieve performance some decades before. What this model has of particular interest? It's one of the more advanced analog multimeters in the sense that it also provides high current measurements, and I think that this is a highlight of this product. Other than that, it's your typical analog multimeter. There are not very many things that could be said about it. There are other multimeters that have a higher measurement range, that have the possibility to measure more accurately at different values. However, this is the current device we're having. And of course, let's also talk about price. When I purchased this multimeter, the price was around 15 euros or the whereabouts of 17, 18 US dollars. So it was not an expensive model, and I was particularly interested in it because similar multimeters were being sold at around 2 or 3 times the price when they were sold from a well-known manufacturer, even if the product itself was clearly using the same platform and almost the same construction as this multimeter. So think about almost 3 times the price with the same feature set, which I consider to be way too much for my expectations. So I decided to purchase this particular analog multimeter. So first of all, let's talk about construction. The multimeter itself has a rubberized casing, which I think has quite a good survivability. Although I have not used it extensively and attempted to make it withstand serious shocks, I think it will fare quite well. It also has a stand, which is another nice feature. The plastic, I think, will hold probably quite well for at least another decade. I'm not entirely sure about the rubberized casing because in general this kind of rubber compounds tend to degrade at after around 10 years, so I'm not entirely sure how this will fare after 5 more years. So it may be able to live well, or it may just degrade and become soft, having the classical problem of being not any longer vulcanized as it was. And it also has probes, and I have to say something about the probes because many times probes are an afterthought for Chinese manufacturers because they strive for the cheapest materials possible and to reach a specific price point. And I think that for a product that was being originally sold at around 15 euros, this one fares very well. I'm pretty sure that the test probes are not to the highest standards, but I think that the cables widened, the construction, the length, the rigidity will withstand quite well many years of use. So this is clearly much above your typical test of probes that are being offered with multimeters. So this is clearly a highlight for this particular model. Other than that, I think you have the typical construction. I have also to mention the switch, and I think that the switch is one of the nicest features of this multimeter. It feels to have an above average switch mechanical feel, which I think lends itself quite well to a lot of use. Of course, I haven't used it quite extensively, so I'm not entirely sure if this will also be relevant in practice, but I think it's nice, and just about as in the case of all analog multimeters, it has a knob that adjusts the zero position for the resistance range, which is typical of these devices. All right, so what else can we say? The scale. The front side, I think, is made out of plastic. It doesn't seem to be made of glass. In this year and age, I don't think this is a major issue unless the plastic gets yellow or degrades in other ways. I think it's quite a good design choice. The scale is nicely laid out, and I think in particular the the needle of this particular multimeter is quite well built, in the sense that it's much clearer what value is being read. And of course, I think that the rest of the construction, particularly the coils and the bearings, I think, lend themselves quite good to accuracy and long time performance. Of course, as I said, I have not used it extensively, but the feel of the construction is clearly above your typical cheap economy multimeter product. And I think that this is clearly one design win of this product. All right, let's look also upon the manual, because I'm interested to see if there is any sort of measurement accuracy or particular detail I can show to you. The manual is not large and is created in the typical fashion you will most likely see with these kind of products. So it doesn't offer any particular detail that is essential, as long as you know what you are doing when measuring. Of course, the typical aspect is that you would never measure currents by directly plugging the probes into a socket. Right, so pointer zero corrector, yes, it's actually the adjustment knob. Range switch, adjuster knob. Okay, yes, they're mentioning this typical adjustment for the zero, and the other one is for the resistance. In general, you should not touch this control unless the device doesn't show the value, doesn't show the zero value right any longer. The volts, ohm, milliamps terms, so milliamps terminal, so this is one of the important connections. The connections are labeled on the front side of the multimeter. So if you're going to plug the red wire in here and you're going to measure volts or ohms or milliamps, you're going to plug it in that position. If you're going to measure AC currents, you're going to use the last position, and if you're going to measure DC currents or ones that are provided from various power supplies and batteries, you're clearly going to use this position. They are also reasonably well mentioned, in the sense of having the ranges in here. However, you will also might use an additional scale in order to be able to better gauge the situation. So for instance, in the case of measuring 500 milliamps, I don't think you will use the scales that are pointed in red. You're going to use the upper one. But this is not a particular concern. You're still going to have the same deviation that you're going to account for. In general, just about as in the case of most analog multimeters, the value you're going to read is highly inaccurate. First of all, it's the inaccuracy of the multimeter itself, and then it's the inaccuracy of your reading. So actually you have to take into account that this was the case, and in general analog multimeters were never very high precision devices, except in situations where they were lab equipment, and in that case they would have greater measurement accuracy, and probably they had even more scales that or even more ranges that could be used, so that you would have a better readout on your device. Right, and if you are looking further, you can see specifications, digital voltage, ranges, accuracy at FCD4, which I don't know exactly what that could mean. Range 600 volts, 5. Frequency response sensitivity 9 kOhms per volt, but this is for AC voltage. In general, you have to take into account the fact that measuring DC voltage has the greatest accuracy, and then measuring currents has the next best accuracy, and when you're getting towards alternative currents, measuring voltages or currents is the least accurate, and probably the worst you're going to encounter is when measuring resistance. This is due to the fact that when you're actually measuring alternating currents, you have to rectify the voltage you are going to measure, and this means that you're going to have reduced accuracy that is being compounded by the rectifying components inside the device. And in the case of resistance measuring, you're going to have additional issues due to the fact that the scale itself is not even proportional, which means that some values can only be read at very small angle deviations, which means that you're going to have a very hard time in ensuring that you read a particular value or not. So it's mostly as a test and nothing more. All right, it was mentioned about FZD. I don't know exactly what FCD means, so I will check just a little. I assume it's something about full-scale deflection, which means that if the device is placed at that range, so it reads about 600 volts, full-scale deflection would mean that at the maximum deflection, when the measured value would be higher, so probably at around on the scale of 600 volts, it would have probably a deviation of 5, or in an inaccuracy of 5 volts, or around 1%. I am not giving too much credit on this particular circumstance, but I think it's a good estimation of what kind of precision you can expect. With a digital multimeter in general, you have greater or better than 1% accuracy. So using an analog multimeter for measurements, it's clearly not a good choice in this day and age. However, for retro purposes, or in cases you want to notice the behavior of a particular device, the way in which the needle fluctuates may show you some very interesting insight in terms of how fast it can deviate or how accurate it is at maintaining a particular value, which has in general a higher sensitivity than digital devices. So these are the only situations where you can consider an analog multimeter to be better. Other than that, it's mostly for retro purposes or for getting yourself accustomed to using a different technology. So let's try and see and make some measurements. First of all, let's measure an AC voltage. So we are going to use the red connector on the volts, ohms and milliamps connector, and the black one in here. The connectors themselves, I think, look quite nice. They are well insulated, which is a good surprise. They also do not stand in the way, which is a major plus, a major benefit on such devices, because in general you would have them going around here, and with a construction that is quite constrained in most circumstances, I think this one would be a less good situation. So I think that with those details out of the way, we have a reference table for reading. Actually, this can be considered quite well even without this reference, just by thinking considering how much of a difference is between two values and dividing that range and seeing how much particular indentation means. So for instance, between 30 and 40 you have 10, and you divide that 10 by the amount of indentations you see over here. So it's 10. It means that each and every position that is being marked is correspondent to a value of 1. And this can be different in the case of the other ranges. You can probably print this or have it nearby for better readings, but in general, when you get accustomed to a particular device, you know this, you feel them, so there is no point in having any particular information. Right, what else is to be said? The scales. Yes, I would also like to mention something about them. Okay, they also present to you how you're going to measure different values. I'm not going to dwell too much upon that. I'm going to have a small saying upon the ranges themselves, as you can see over here. So you have 2.5 volts, so this will be perfect for checking the voltage of a typical battery. 10 volts, again, other batteries and probably power supplies. 50 volts, this would cover most devices that you will probably have that use semiconductors or integrated circuits. 250 volts, this is mains voltage. Probably you're going to measure your voltage that comes from a rectified mains voltage, not the main voltage itself, and I'm not recommending you to use the direct current range to measure AC voltage. In general, your device is not going to be hurt, but keep in mind that you're not going to measure something that is going to be relevant. Probably the measurements should stay at a different value, but it's not going to be relevant. AC voltage range 10, 15, 50, sorry, 250 and 600 volts. So it covers most of what you would need in this respect, but you notice that there isn't any position for smaller voltages. In general, when you don't have a particular range for a value, your accuracy is going to be limited. So in here, if you would have let's say 250 millivolts or 500 millivolts, then you would have the ability to measure lower voltages much more accurately. But this device clearly is not made for such a purpose. You have the small currents range, 500 milliamps, 250 milliamps and 10 milliamps, which cover most of the currents you would probably encounter in smaller circuits. The same goes for DC currents as well as AC currents. I was expecting this one to be alternative current because it's using the same color. Unfortunately, the manufacturer has not been consistent and used this kind of color in order to represent um, the alternative measurements, and this one for the direct current measurements, which I think is wrong. It's inconsistent, but anyway, it was their design choice. And then you have the high current range, 10 amps for DC voltages and 10 amps for alternative currents. It's important to know that when measuring any current, you should be measuring in series. If you're going to measure in parallel, or you're just going to plug the device as you would when measuring a voltage, you may damage the device. You may have noticed something very interesting. There is, of course, or there should be, and over here you can clearly see that there is a fuse inside the device that should protect the multimeter in case of wrong usage. Hopefully, and this is very good, it has not only a fuse for the lower current range, it also has one for the high currents, and I think this one is good, although I'm not expecting the fuses themselves to be of the highest quality. Again, the device was built for price, but ultimately the fact that it also protects the high current range, I think, is a major plus. Most devices do not have a fuse that cover high currents, and particularly not for a device that is priced this low. So I think this is good. We will also see inside the device. But anyway, I made a very long talk about it, and I have not shown any sort of measurement. So let's do such a measurement. So I'm going to change the range towards 2.5 volts, because this is what we are going to make an attempt to see, and I'm expecting around 1.26 volts. So if I'm going to read 1.25, I'm going to consider this as being good enough. So we are looking on the range that you see over here, 250, and we are going to consider that it's from 0 to 2.5 volts. So let's see. And in this case, of course, we have to use the correct polarity, because if you are going to use the opposite one, we are going to read it wrong. Just for showing you what happens, but I'm going to use it very slowly. Try not to do this, but in case you're doing, just make a connection for a very brief moment. The needle is going to deviate in the wrong position and may damage the device if it's going to be used for longer. But for instructional purposes, I'm going to show you what happens. So as you can see, the needle deviates in the opposite position, and this means that it can be damaged. So let's see right now. All right, we have a reading of around almost 125. Okay, the reading on a digital device was 126, so I think we are quite close to the expected precision. All right, I'm going to take another battery, and I'm expecting roughly the same value. Okay, again, almost 1.25 volts, so it's quite all right. I'm going to show you also the reading on the mains voltage, but I'm going to plug it in a socket that you're not going to be able to see from this position. I'm going to make sure that I placed it in the right position, so it's alternative current. I use the right connector, and right now let's plug it and see what the readout is going to be. Sorry, let's make sure we make a good connection. And it reads at around 200, a bit above 225 volts. So I think it's quite all right. If I remember correctly, when using digital device, the measurement was around 226 volts. So I think that this particular multimeter's accuracy is quite well in this respect as well. As I said, it's not going to be stellar, and particularly when measuring AC voltages or currents. Alright, and let's also show you other features. We are going to switch to current measurements, and I have to switch from this position to this one in order to measure DC currents. Alright. 3.73 amps, and let's see if the readout is going to be consistent. It read at almost 4 amps, a bit above 4 amps, if I consider it rightly, yes. A bit below 4 amps. A bit above, okay, so 4 and something amps. In general, you have to consider that measuring high currents is not going to be particularly accurate. You have to use the same device and the same battery in order to be consistent in your readings. So I think that this is not going to be an issue. It depends on how much current each and every multimeter draws. And right now, let's show you the last values you may be interested in, or the last measurements. You have the ability to have a small beeper, so when continuity is ensured, you're going to have that. Of course, we have to plug it again into the first connector, as mentioned over here, which is not entirely obvious, but you have to get used to that. You will also have to use the same logic when using any sort of digital multimeter, at least for the moment, although I'm pretty sure more advanced devices will also make this feature automatically switching. Okay, I should have used that. And as you can see, the beeper works. It's not a very strong beeper, which sometimes may be a nuisance. It's not a very weak one. I think it's quite alright. Perhaps in some circumstances it would have been better to also have a LED that would shine on the scale so that you would know when the beeper would sound in case the environment you are measuring in is quite noisy. Alright, and let's see the resistance measurement. Alright, we have reached the end of the scale and it's at 0, so we don't have to use the adjustment knob, at least for now. And let's see the other range. And as you can notice, there is a slight deviation. So even when considering the fact that you would use the device from one scale to another, the accuracy is going to be reduced because you would have to contend with using the adjustment in order to reach the 0 range. So this is one of the reasons why measuring resistance with analog multimeter was always just a rough guess of what component would have. So if you would know the value that you would read from the component itself, from the resistor or from another device, you would have much better information than checking the resistance with the multimeter. This would only show roughly if the value is within the range you would expect. It would never show more than that. Alright, so the last part of interest is, of course, seeing what is inside the device. And due to this, I think I will resort to disassembly and show you. I have to mention another aspect, the fact that it uses free AAA batteries, but you have to use these batteries only for the beeper and for the resistance measurement. So the other types of measurements, the current and the voltage measurements, do not require batteries. This is a surprise for most users in this day and age, but these devices can be used reliably without a battery in most circumstances in order to have a rough estimation of your device's operation. And I think that the connectors inside are quite well built. Unfortunately, they don't have the typical flat connector for the positive end of the battery, which would mean that you would have to fiddle a bit in order to have a good contact and a good placement of the battery. Otherwise it would not be able to have the slider well placed, and then there would be a bulge on the lower side of the multimeter. Right, we are using over here your standard Phillips head screws. I don't think I need to take again out this screw, but we will see. Okay. All right, and we are seeing the internals. Well, I have to say that they are surprisingly well built, and I think that everything about this device is clearly above the typical quality you would see. And I will mention some of my concerns. The first one is that each and every connector has a strong mounting system, and you can see the connectors over here, the crimped connectors. Each of them has a screw, so this means a solid connection, and I think this one is clearly a plus. I'm noticing good protection of the delicate end of the analog multimeter, and I'm seeing very good fuses. I'm not entirely sure if they also have sand in them and if they are built entirely to specifications, but they are clearly much above your typical fuse. Most fuses are only rated for a couple of 100 amps, and they use the typical glass construction, which cannot quite well withstand high currents or high stress. And this is a very good choice. All the other components are well laid, as you can see. They are even using surface mounted components. They are well distanced. There may be a situation where the high voltages may not be separated enough, but keep in mind that this device cannot measure more than 600 volts, so it's not required to have such a good capability. And we also take a look at the high current measurement cables, and I think they are thick enough in order to withstand use, and they have low enough resistance to be able to make accurate measurements. And we also see various ports that can be reliably used to calibrate the device. So overall, I think that clearly this is a step above your typical analog multimeters, and particularly for a model that probably costs around 20 euros today. I think that it's very well suited. My only complaint would be that almost certainly these cables do not use copper conductors. They use probably aluminum ones, or they use a mix of aluminum and copper, as happens in other cables. So I'm not expecting the cables to be particularly having the best conductivity and the best resistance, but clearly they are not bad. And Chinese manufacturers for a long time have been switching from using expensive materials like copper to aluminum. So having a cable that has enough thickness in order to carry the current is still quite well. And the layout of the board is quite clean. I'm seeing also some solders that seem to be made quite well. So overall, I am pleasantly surprised about the quality. And those two resistors that measure the voltage drop on high and low currents are well spaced from the device, which would mean that the device has typically good behavior when measuring these currents. With most multimeters, these very low resistance connections, these shunts, are placed very close to the board itself, which would mean that extensive wood use would probably release a lot of heat and damage the board much more easily. And the second one is that they would not be created with so much thought about their construction. So clearly the build of this device is much above the others, and I can understand why some of them could be sold at a price that was almost 3 times higher or 4 times higher than this particular device with the same design, because the design is very well. I'm not saying that you should pay around 40 euros or the whereabouts for such an analog device, but ultimately it depends upon the situation. If you are going to consider this acceptable or not. So I'm going to screw again the casing and mention my final thoughts. What I would have liked this device to have is clearly a much higher range. Unfortunately, this device in particular has been quite difficult to find, and I think that this was one of the reasons why I could not make a better purchase. I would have liked to have a device that would be able to measure more at a much more comprehensive range, but this was the situation. In terms of construction, I do not have any complaints. Even the screws themselves look to have quite a good quality, so they could withstand humidity and other situations, which is again a surprise for a device that was not overly expensive. And I think that just about everything about this analog device, again, if you can find it available for purchasing, clearly show that it's one that is a clear recommendation. Of course, as mentioned, it has its shortcomings, just about any analog multimeter, but I think that where it actually shines, it does so very well. And particularly for a beginner, having so many fuses and having them well placed is an advantage, because accidents happen even for professionals. So overall, I think it's a wonderful device, and one you would probably enjoy to use a lot of time. And probably if you have fond memories of using an analog multimeter, or you are starting to get fond of them, it's a very good product to have and to use just about every day. So, hoping you enjoyed the video. I have my final thoughts on them. And even about packaging, I have to say that it's not bad. It was using a bubble sheet, so it would not withstand severe shocks, and the rest of the device has already been well presented. So if you think about purchasing an analog multimeter, this one is clearly very good. I have to mention in passing the fact that models without the A designation should have a much higher measurement range, so probably to have to show you a bit of an expectation regarding them. I think that they have the capability to measure up to 1000 volts. In terms of the current range, I think it's much wider, and the resistance one as well. Let me see if I can find more details. Just a moment. Okay, yes, I found the details. So you would probably have the ability to have measurements with high precision up to a level of, so you would receive, just a moment, The 10 ohms, the 1 ohm range, which would be having a better accuracy than the 10 ohm range, particularly when mentioning the issues with scale, and probably one that would be for over 1 kilo, probably 100 kilo ohms or something like that. 100 or 10 kilo ohms, which would make it available to measure higher resistances. Of course, in general, analog multimeters do not measure higher currents, higher resistances. The DC current range would have much more options. It would have 1 milliamps, 2.5 milliamps, 10 milliamps, 25 milliamps, and it would go to 100 and reach even 1000 milliamps, so 1 amp. This would mean that you would have higher accuracy when you would measure a particular current or voltage. And in the case of voltage, you would have 2.5 volts as here, 10 volts as here, 25, which is not present, 100, again not present, 250, which is present over here, and 1000 volts. So you'd have much better accuracy when looking at a particular value and making sure it reaches. But overall, as mentioned, it's a great device. If you find it on sale on Amazon, on eBay, or just about any shop, it's a clear recommendation if you are searching for an analog multimeter. And even if you are not searching for an analog multimeter yet, you would like to have one and see what's capable of, it's a very good starting point. I don't think you will ever be disappointed with a device, even if it has this designation and it's a much more limited one, or if it's an EM345, which has much more measurement capabilities, so much more accurate measurement capabilities. So overall, a very good device. I really recommend it to you, and I hope if you find one, you're going to be enjoying it as well. So thank you very much for watching, and have a pleasant day.